Hello everyone, welcome to my YouTube channel. Today I'm going to solve the question which asks how many chiral carbons are there in beta-D glucose. So I have already solved this question before. I'm just trying to tell it via video that what does it mean. So I've solved this question a while ago. So glucose can be shown either in a Fisher projection way or Howard's projection way. So in Fisher projection, you can show it as a D-glucose or L-glucose. And I'm just giving an example of how D-glucose looks like. It's a straight chain, and it's easier to find the chirality of a carbon by just counting whether the carbon has 4 different bonds or not. So just a basic example I've given here, that when you call a chiral carbon, it means that the carbon is connected to 4 different bonds. In this, the examples here, it's just a alphabetical example I'm saying. So for example, this is a carbon, then the 4 different bonds would be X, Z, W, Y. So if just, for an example, if these 2 bonds are X, then you could not say that it's a chiral carbon. So it has to be 4 different bonds to be able for carbon to called as chiral carbon. So this is just a general example. And for that, I've just shown you here how you can easily calculate the chirality of a D-glucose because it's a straight chain. So you can just start from one side of the chain, and then you can go further to find out which particular carbon has 4 different bonds. So for example, if you look at this carbon, which is 2, so I've just rounded the particular bond. So you can see the first, let's say this is X, this is Y, this is W, the whole thing, and this is Z. So you can see all these 4 molecules are different from each other, and that's why second number carbon is a chiral carbon, right? So this is what I have told you here, that it's easy to calculate chirality of a straight chain, the carbon in a straight chain. The question here is, how would you calculate the chirality of carbons in beta-D glucose? Now again, in Howard's projection, you can show the different sort of structure, for example, alpha-D glucose and beta-D glucose. The question here is how many chiral carbons are there in beta-D glucose? I'm just ignoring the alpha-D glucose, and similarly, I've ignored the L-glucose in Fisher projection. So in beta-D glucose, you can again, so it's a different way to calculating the chirality in circular structure. So let's focus on the first carbon here. I'm just pointing it out here with the arrow. So let's just focus here for solving the first chiral carbon. So let's say X here is OH, Y is H, Z is O, and the W is HCOH. So we're just focusing on this carbon. So when you're trying to solve the chiral, whether the carbon is chiral or not, you have to look around the 4 bonds. So you would be able to simply figure out that the 2 of the bonds are OH and H. It becomes difficult when you're trying to find other 2 bonds. So you just have to see the nearest bonds. So here it's one side it's O, and the other side is HCOH. So what you see here is that all of these 4 are different. So straight away you can say that this particular carbon is chiral. Now let's go to the second page and let's try to see for the C2. So you can see the arrow here for this particular carbon. So you can again do it like X, Z, W, Y. So let's say the first bond is X, which is HCOH again. The second one is H, third is OH, and the last one is HCOH. So now again, it's becoming difficult because now you know that these 2 are different, but again, these 2, the X and the W, are similar. So you don't have to worry here, and you definitely need not to be stuck here. What you can do here is to just write it down in your notebook that X is this, Y is this, Z is this, W is this. So you will go to the next step. Next step means you will go further. So let's see here again. So now you know Y is H, Z is OH. Now you can go one step forward in both of this. So in here you can see now instead of HCOH, you also have one more atom involved, one more molecule involved here, that is O. And in here also you can see HCOH, and there's another molecule involved here that's again HCOH. Now you can again write the 4 different bonds here. So X is HCOH, Y is H, Z is OH, W is HCHO, HCHO. So I've just simply written it out in terms of atoms. So you can now see X and W are different. Here, when you did it for the first time, maybe you were stuck that because X and W are same. So now you don't know whether it's chiral or not. So you can move further to find out that now X and W are different. So you would be able to figure out, okay, so why W and X are different. So you can definitely say that this particular carbon is chiral as well. So this is how we proceed in determining chirality of the structure which is circular in nature. So it's not as difficult as it seems like. You just have to be logical and you can write the steps as you go. It will be easy for you to find the chirality in something which is circular in nature. So similarly, you can do for others. So I have shown you a very easy example of this particular carbon and a difficult example of this particular carbon. So you can go further. So when you start from here, then you went there, and now again, you can do the same thing for C3, C4, C5, and so on and so forth. So once you would be able to figure that out, you would know that the beta D glucose have total carbon, chiral carbon as 5. So you can see that in D glucose, there were 4 chiral carbons, but in beta D glucose, there are 5 chiral carbon in the structure. So I hope that you would be able to do this by yourself now. So, and the other thing I wanted you to do is this is just a presentation of how you can find the chiral just by writing. But if once you are pro in that, once you know how to do that, you can also use certain software. For example, I can show you there's a software called ChemDraw. I'm not very sure if it's free or not, but you can definitely try downloading it. So this software, you can just make the structure and automatically you can just choose that particular option of finding the stereo structures and stereochemistry, and then it will just tell you how many chiral carbons are there. For example, I'm just going to go to structure and I'll say convert name to structure. So I will say beta D glucose and you click OK. So here is your beta D glucose ready. You don't even have to do anything. So now the next thing you have to do is right click here, go to atom and say show stereochemistry. Now you can see how many stereo chemical center are. So 1, 2, 3, 4, 5. So that's beta D glucose, and that's what we have figured it out in here. Now, if you want to compare alpha D glucose with beta D glucose, what you can do is go to structure again, convert name to structure. Instead of beta, write alpha. And say okay. Oops. Yeah, you can drag it here because it has just overlapped. So you can see the alpha D glucose and beta D glucose, and you can again right click here and go to atom and say show stereochemistry. Now you can easily figure out the difference between alpha and beta D glucose. You can see what is the difference is just here. So the rest is RSSR, RSSR. The only difference is that this carbon. So in alpha D glucose it's S, and in beta D glucose it's R. So this software is it's easily calculating the stereochemistry for you. So it's just, but either way, you have to at least understand the logic behind why and how you can calculate the chirality of certain structure. And you can also compare with the normal just D glucose, that's the Fischer projection. So again, I'm going to say write D glucose. So you can just again drag it here. And let's see the stereochemistry for this one. Atom, show. Now you can see 1, 2, 3, 4. So there are only 4 chiral carbon in this structure, while in the circular one, alpha or beta, there are 5 chiral carbon. So that's all from my side. I hope that this question, you have understood this question properly and you would be able to solve such questions properly from now on. Thank you.